And there we go. So thanks very much for coming along to Knots IoT tonight. Before we get going, we do have a code of conduct here, which we'll show on the screen in a second. There we go. Really, it boils down to this box in the bottom right-hand corner. Be kind and considerate to others. So essentially, if anybody feels as though any of this is being broken in any way, then by all means send myself a chat in the message there, and I'll endeavour to put things right and make sure that everyone's all happy again. So tonight we are sponsored by PJG Creations, which is my company that runs in the background that sponsors things like the web hosting and fees and bits and bobs like that. We're also sponsored by Raspberry Pi, who kindly send us some kit from time to time to hand out to lucky folk that come along to the calls. And we're also sponsored by Rebel, who are hosting our video conferencing side here on Zoom. So thanks to them for sponsoring that. I'm a Microsoft MVP, and I'm joined actually by, three, but two presenting Microsoft employees as well. Being a Microsoft MVP is a result of working in the community alongside things like open source, or speaking in the community, or organising events like this one. And you do enough of that and you get recognised, and then you get to work directly with the product groups like you have on this call here to help steer direction of product, which is one of the great perks of being an MVP. So tonight we have Seeam Islam and Isabella Calandriello. Is that pronounced right? Is that you pronounce your last name right there? That's
Yeah.
one less L. I had too many L's in Isabella's name there originally, so quickly corrected. So Seeam and Isabella will be talking about what's new in the Azure IoT Hub around managing devices, certificates, and updates at scale. Normally we would have an announcement for another meetup. There is a possibility we'll have one next month, but there's a very good chance that we'll go on holiday for the summer and we'll likely be back in September. So keep your eyes open on social media for when the next one of these events is. So with that, I will stop sharing and waffling, and I'll hand over to Seeam and Isabella to kick us off.
Oh,
Thanks,
let me share my screen. Let me know if you're able to see my slide deck.
Yeah.
Cool, perfect. Awesome. Thanks so much, everyone, for joining us today in this session. Today, my colleague Isabella and I will be talking to you about the latest releases across the Azure Connected Devices platform, namely the new investments we're making across Azure Device Registry, IoT Hub, device provisioning, and device updates. So to kick off, a quick introduction. I'm CM. I'm currently a product manager here at Microsoft, working across the Azure portfolio for connected operations. I focus on the product strategy for device security and identity across our stack. As of today, I drive our new certificate management service in Azure Device Registry that was launched at Microsoft Ignite in late 2025. And I'll pass it quickly to Isabella to introduce yourself.
Yes. Hello, everyone. And thank you so much for tuning in. And thank you so much, Peter, as well, for that great intro. So as you know on the slide, my name is Isabella, and I've been a product manager at Microsoft for a bit over 2 years. And I am working on the Azure IoT space, just as CM, but with a focus on Azure Device Update for IoT Hub. So super excited to be sharing with you some of the latest things on ADU. Pass it back to you, CM.
Wait, so before we get started, let me give you a quick heads up of what we'll be discussing today, so you know ultimately what's coming. So we'll kick off with the big picture, namely touching on Azure's adaptive cloud architecture, which is the foundation for essentially everything that we'll be talking about today, and how we empower devices, whether they're out in the field or connecting directly up to Azure to the cloud or running locally on the edge. From there, we'll get into the heart of it, namely what's new in Azure IoT Hub. And there are three primary things that we're super excited to share about. First, Azure Device Registry integration, which is a single unified registry for managing all of your assets and devices as Azure resources. Second, certificate management for IoT, making it far simpler to issue, renew, and revoke the certificates that keep your devices secure. And third, Delta updates for IoT, a smarter, lighter way to push updates to your fleet without actually shipping the entire software image each time. And then comes one of my favorite parts, which is the demos. First, I'll be demoing how to use an external certificate authority for X509 certificate provisioning, and then we'll see Delta updates in action. So lastly, we'll wrap up with a Q&A. So hold on to any questions that you might have, and then we'll address them towards the end of the presentation. Cool. So let's begin with the big picture. And it all starts with Azure's adaptive cloud approach. So the Azure platform for connected devices is super extensive. You have products that have been in market for nearly a decade, like Azure IoT Hub, and products that were recently released, like Azure IoT Operations. Both of these products are key components of the Azure adaptive cloud approach, and each serve a unique purpose. Now, let me put you into the shoes of some of our users. Say I'm a global manufacturing and logistics company that operates multiple factories and dozens of delivery vehicles across the state of Washington. Like many businesses today, my operations are geo-distributed and actually live in two very different environments at once, being inside my factory, so on-site, and outside on the road. As a result, I need specific solutions that satisfy each one of these two environments. And let me walk you through each of these. So first, my vehicle fleet. I've got a huge number of connected vehicles out on the road, and while they're driving around, I need each one of them to send data like their location back to me so my team can monitor the whole fleet in real time. For that, my vehicles need to connect directly to the cloud, and that's where Azure IoT Hub comes into play. Because I'm operating so many vehicles, I can't onboard them one by one, so I provision them in bulk. Each one automatically registers itself to the right IoT hub and starts streaming telemetry straight to the cloud. So that's my first environment. Devices are always on the move, talking directly to the cloud. Now back at my factory, it's a completely different story. Here I've got small devices, sensors, PLCs across my entire assembly line. And the last thing I really want in my factory is for all of these small devices to be fighting over, one Wi-Fi or internet connection. Instead, I want them to operate right at the edge. So I put a local MQTT broker on site that aggregates, filters, and normalizes all of the data before any of it actually leaves the building. And that's where Azure IoT Operation comes into play. It runs locally on my own hardware powered by Azure Arc, and its connectors speak the industrial languages of my various equipment, like OPC UA, OnVIF, and MQTT. And so everything plugs right in, and all of the heavy processing happens locally. And that's my second environment, devices running at the edge. So now I've got these two very different setups, a cloud-connected fleet out on the road and an edge-powered factory back at home. And here's the part that ties it all together. No matter how my devices connect up to Azure, whether that be through directly to the cloud or on the edge, it's all managed in one place, which is the Azure Device Registry, a single unified resource manager for all of my IoT assets and devices. And finally, all that trusted telemetry from the vehicles in the factory flow into Microsoft Fabric, where it becomes one unified stream that I can actually put to work. So things like fueling AI agents, creating AI-powered workflows that ultimately are able to turn raw data into real-time insights and automations across my whole business. And that's the Azure Adaptive Cloud approach in a nutshell. One company essentially operating multiple different worlds, but devices connecting directly through various Azure services, where that data ends up in one unified data platform so that it can all feed into the same intelligent data models. So with that picture in mind, let's now dig into the focus of today's presentation, which is what's exactly new in Azure IoT Hub. So Azure IoT Hub, it's currently our generally available service that lets users running in production right now. And at its core, it's the front door between your devices in the field and the cloud. That said, we're actively investing in Azure IoT Hub with new investments being made every month. And in the next stage of IoT Hub, our focus was really to tackle some of the existing limitations with the platform, such as modernizing the architecture to align with newer Microsoft and IoT services, and strengthen our security posture so that it's easier for organizations to adopt the best practices. So of these investments, the first thing that we'll be doing is integrating with Azure Device Registry. So as I mentioned, Azure Device Registry, or ADR, it gives you a unified single plane for managing all of your assets and devices kind of in one place. Second, we're introducing certificate management to Azure IoT Hub. So this is where you can use a Microsoft-backed PKI or even bring your own private PKI to manage the full life cycle of certificates for your devices. So everything from certificate issuance, renewal, and revocation, and more on that in the next few slides. And third, Azure Device Update, ADU, which now supports Delta updates. So that now you're shipping just the difference between versions across your updates rather than a full image each time. And we'll be digging into later how that actually works. There's also a set of add-on services that we'll continue to offer with this architecture that users know and love today, such as device provisioning, Azure monitoring, etc. And so all of these components actually live within your ADR namespace now. And so you can pick and choose exactly which components you need and build the flexible, secure solution that your organization needs in order to empower your IoT operations. So now diving deeper into the specific new investments. So the first investment I mentioned is Azure Device Registry, or ADR. It's a new Azure resource provider that centralizes device management for IoT. So here, every device that connects to IoT Hub is represented as an ARM resource. And the moment it's an ARM resource, it inherits everything that you would expect from Azure. So things like unified management, role-based access control to govern, who can actually manage these devices, Azure policy, tagging, and more. Second, it's integrated and application agnostic, meaning whether a device connects through IoT Hub or through Azure IoT Operations, it lives in the same registry. So instead of having each IoT Hub having its own isolated registry, ADR gives you one global control plane. And within ADR, we're introducing namespaces, which are essentially logical containers that can help you organize assets and devices across your entire organization for better segmentation and scale. Third, ADR is being directly integrated with other Azure IoT services. So things like device provisioning and certificate management all linked to a single ADR namespace now. Another big investment we're making in Hub is bringing Microsoft-backed X509 certificate management to IoT. So to set the stage, think about it today. If you wanted to secure your device-to-cloud communications with X509 certificates, as an organization, you're responsible for standing up your own third-party PKI, configuring certificate authorities, syncing those certificate authorities with IoT Hub, procuring certificates, et cetera, et cetera. And we know that process is super complex and difficult to get running. And so those are the exact capabilities that we now provide out of box. So the first pillar of certificate management is out-of-box support for certificate authority infrastructure. So instead of hosting and wiring up your own PKI, you get an Azure managed PKI behind the scenes that can manage your certificate authorities and issue device certificates directly within your IoT solution. Second is lifecycle management. So we provide deep workflow integrations for certificate issuance, renewal, and revocation. So certificates are issued and renewed automatically, keeping your fleet routinely secured, no matter how big or small. And lastly, we support certificate revocation. So say there's a compromise within your fleet or within your organization, you can revoke device credentials right away to cut off its communication with Azure IoT Hub. With certificate management, we also introduce a strong level of configurability. So we understand that each organization has different security needs depending on the product category, business function, etc. And so we've designed certificate management to be policy driven. You can actually design your certificates and credentials to meet your own compliance needs by configuring things like certificate lifespans, etc. And lastly, I want to reiterate that security is the foundation of certificate management. The certificate authorities themselves are created and protected using Azure managed HSM keys. So your root of trust is backed by hardware grade protection, not just software. And tying this all together, this all lives right inside your ADR namespace. And that's how we deliver at scale one place to manage device certificates across all of your Azure IoT devices that connect to IoT Hub. And with that being said, we can now move on to the demo where I'll be demoing how I can integrate a private certificate authority, so one from a third-party PKI, to ADR to issue certificates to my actual devices to connect to IoT Hub. So give me 1 second to change the screen that I'm sharing. And let me jump to a different one. One second. Share the right screen.
This literally is the online equivalent of having to swap HDMIs.
Yeah. Let me know if you're able to see my Azure portal.
We can.
Perfect, cool. So I currently have my Azure portal open where I have one resource group currently created. And this resource group currently contains everything that I need to get started with my IoT solution using all of the new public preview capabilities. So first and foremost, I have my ADR namespace. As I mentioned, my ADR namespace is essentially my management plane for my IoT devices now, as well as my linked resources like my hubs and DPSs. This is also where I'm going to go to create my certificate management solution and manage these device certificates. Second, I have my Azure IoT Hub, which continues to be the place that my devices are communicating with to enable bidirectional communication and whatnot. And these IoT hubs are now automatically synced with my public CA certificates so that devices that present a Microsoft-backed certificate are able to authenticate themselves and send trusted telemetry. Third, I have my device provisioning service. So this is essentially how my devices will onboard onto IoT Hub for the first time and continue to be registered with an ADR. GPS has also been updated so that devices can request certificates as part of DPS provisioning, so that certificate issuance and renewal are now deeply integrated within the DPS experience for devices. Lastly, I have my user assigned managed identity, which is essentially a managed identity that possesses all of the necessary privileges to link these resources together. So first, I'm going to jump into my ADR namespace right here. And I'm going to go to my credential policies tab. This is where I'm going to go to enable certificate management and create policies that essentially map to certificate authorities in my PKI. So first, by enabling certificate management, I'm going to create an Azure managed PKI dedicated strictly for my ADR namespace. So the benefit here is that no two namespaces share the same PKI or certificate authorities. Everything is unique per ADR namespace that enables certificate management. I'll give that a second to create. Cool. So now that I've enabled certificate management, I've default created a root certificate authority. So this is going to be the topmost certificate authority in my PKI hierarchy. And now I'm going to be creating policies, which are essentially intermediate certificate authorities that will chain up to either this root CA or a root CA that I might have in a private PKI. And that's actually going to be what I'll be demoing today. So I'm going to go ahead and create a policy. I'm going to just name a policy not IoT. I'm going to set my validity period. So this defines the lifespan of all of the certificates that are issued by the certificate authority. So let's just say 30 days. And now I'm going to configure the certificate authority so it chains to an external CA that's hosted in another PKI that I have. So let me go ahead and create this. And so now, because my root CA that I want to chain this to exists in a private PKI, I need to go through a couple more steps to ensure that this Microsoft ICA is able to chain up to that external CA. So let me give this a couple seconds to create. Cool, it's created. So now I have to go through this flow where essentially I have this ICA that was created within my ADR's PKI. But now what I need to do is I need to have this ICA signed by a CA that's in my private PKI that's on-prem. And so how I do that is I download a certificate signing request file that was generated by this Microsoft ICA. And I'm going to take this file. So I'm going to take that file, the CSR, and now I want to have it signed by my private PKI. So I'm going to paste it here in this folder. And so now I have this code right here where essentially I'm going to create a private PKI with a root certificate authority. I'm going to upload that CSR that I just downloaded. And then I'm going to have that CSR signed by my external root. And so now let me run that script right now, which is going to build my entire PKI and sign that CSR file. So boom, I've uploaded my CSR. I started signing the CSR with my root CA that was created over here. So I have a self-signed root CA as they always are. I'm going to sign that CSR and then I'm going to upload it back into my folder. So now I have this file known as BYOR certificate chain. This is essentially the full certificate chain now. So I'm going to have my root CA in here, and then I'm going to have my intermediate CA chain in there as well. And so I'm going to take that and I'm going to upload it back to my ICA on ADR. And what this is going to do is essentially patch my ICA that's an ADR so that now it's formally chained to my certificate authority that I created outside of Azure. Give that a couple seconds. Cool. So I've successfully activated my new policy. And so there are a couple more steps that I want to do before I can start provisioning devices. First and foremost, I want to sync my CA certificates with my IoT hubs. What this essentially does is that now these CA certificates get pushed over to IoT Hub. So any devices that connect with a certificate issued by my ADR are able to be authenticated properly. So I'm going to sync that. In the meantime, I'm going to do one other step. So I'm going to go back to my DPS and I'm going to go to my enrollments. So enrollment groups are essentially how your DPS knows which IoT hubs to provision your devices to. Your enrollments also now decide which policy or CA gets applied to your devices at the time of provisioning. So I'm going to link that policy that I just created to my DPS enrollment group. And now my DPS knows exactly which policy to apply to my devices. And so I'm going to wait for this, for these policies to finish syncing, and then we can start provisioning devices. In the meantime, we can start getting my device set up. So I'm going to now open up a simulated device that I have. So for the sake of this demo, we have this simulated device created where essentially this device is going to now connect to IoT Hub using an onboarding credential and then request a certificate from the CA that we just created. So I'm going to quickly throw in some of the necessary properties to have this device connected. So I'm going to set my DPS ID scope. I'm going to set a name for this device. Let's call it, or just to be more specific, we'll call it CM, not IoT. And then As part of DPS, I need to provide an onboarding credential to the service so that it can verify my device before it gets registered. This is separate from the certificate that my device is going to receive to connect to IoT Hub to send telemetry to. And so I'm going to paste an enrollment group key here. FYI, never share your enrollment keys like this. I'm just doing this for the sake of a demo. I'm going to paste this and I'm going to start provisioning my device. So as you can see, my device is trying to connect to DPS for the very first time using a SAS key. And it's sending over a certificate signing request file in the same operation. So right here, I get this notification saying, okay, my DPS returned a successful response, meaning my device has been connected to an IoT Hub. Now, IoT Hub and ADR, they want to send a certificate back to my device to have installed. My device wants to install this certificate so we can use the certificate to now communicate directly with IoT Hub using the certificate. So I'm going to go ahead and install the trusted root CA and ICA that were just created, as well as a leaf certificate onto my machine, which is my IoT device. And so boom, my device is now completed provisioning, and now I can connect to IoT Hub and send trusted telemetry. So now my simulated device is sending data about wind speeds to my IoT Hub, which I'm actually able to open up my IoT Hub and see that now. So I'm going to go back to my portal right here. I'm going to hit refresh. So as you can see, I now have a new Azure resource here. I have that same device that I just provisioned to IoT Hub and ADR, which is represented within my ADR namespace. So right here under my devices, I can see that device here that was successfully provisioned. At the same time, that same device is sending telemetry to my IoT Hub simultaneously. And it's all doing that by authenticating with that certificate that was issued by ADR to the device. And what's really cool about this is because my device is constantly sending data to IoT Hub, so it's even sending device twin properties, where my device is reading the properties of the certificate, sending it to IoT Hub, which is then streaming it all the way up to Microsoft Fabric. So lastly, I have Microsoft Fabric open right here, where I have my many hundreds of IoT devices connected and sending telemetry all the time. That same IoT device that I just provisioned is actually sending telemetry right away to IoT Hub. So it has the same certificate that was just issued to the device, and I'm able to monitor my certificates and devices in real time here using Microsoft Fabric, because my IoT Hub is routing this telemetry and these device twin properties to Fabric in real time for me to analyze. So that's one of the powerful integrations that we support between IoT Hub and Microsoft Fabric. And so if I open up this device right here, I can see all of those device twin properties that my device is sending in real time. And so as an admin or something like that, I'm able to constantly monitor my devices and govern that everything is operating correctly. So the very last thing that I want to show you is now I have my device registered here on ADR. Let's say something happens to my device. There's a compromise that my device was stolen, and so I need to decommission it from connecting to from IoT Hub at all. What I can do now is I can actually revoke my device certificates and disable it. What this will do is that it'll add this device certificate to my certificate authorities revocation list, as well as block any and all telemetry coming from this device to IoT Hub and ADR until I've re-enabled and reissued a new certificate. So I can go ahead and revoke the certificate. Give that a second. Cool, so it's been revoked. And then we can try connecting again. So I sent a ton of telemetry here. And then boom, connect failed, refuse, not authorized. Because I revoked this device certificate, my device no longer has a valid certificate in order to communicate with the IoT Hub. The only way that my device can recover itself is if it reprovisions with DPS from the beginning again. And so this is a way that administrators can revoke access for any compromised devices across their fleet. And with that being said, that concludes my demonstration. I hope you folks enjoyed that and gave you a good taste of the new capabilities that came to IoT Hub, ADR, and DPS for certificate management.
That's really cool to see all of those features. I've seen a fair amount of that before, but there's even new stuff since the last time I looked, which is awesome to see. Love that demo and super powerful as well. I think on that DPS side, you were connecting with a SAS key essentially there, weren't you?
Yeah.
You could use a certificate there, just the same, but it kind of feels easier. What is the recommended process from Microsoft on that? Do they recommend you use a certificate at all times, or is it perfectly acceptable to use a SAS key to onboard through ADR?
Yeah, as part of DPS provisioning, it's perfectly okay to use any of the trusted authentication methods that DPS currently supports. So we support SAS tokens, X509 certificates, TPM as well.
Yeah.
X509 will be more secure for IoT workflows rather than SAS, like that's a given. And so that's why we make it easier that once your device, provisions to DPS with some sort of like other mechanism, is that we issue certificates now to ensure it can communicate back and forth with IoT Hub. These onboarding credentials that the device uses to connect to DPS, they're generally burned onto the device during manufacturing time or when the device is being prepared. And so certificates are not always as viable or feasible at that given time. But once a device is successfully provisioned to IoT Hub, then a certificate is definitely the best way to continue communicating back and forth with the service.
Yeah, that's true. And I think a lot of people find it harder to manage X509 certificates generally. And
Yep.
so these sorts of features are fantastic to see because we should be, I don't know, gently pushing people to use X509 or something more secure than SAS keys personally, I think. And so the more we can do to make that a bit more accessible for people, the better. And certainly having a Microsoft-backed PKI there, I think, is a great way to go and add some trust and some simplicity of design for that as well. So, yeah, I love all of
Yeah,
that.
absolutely. I'd say the hardest part of using X509 with IoT is the process of issuing and renewing certificates for devices that are out in the field where you don't have easy access to. And this really solves a major problem because now certificate issuance and renewal are deeply integrated with IoT workflows like device provisioning. So if you get started with the device SDK, certificate provisioning is directly integrated within those SDKs now. And so now as part of DPS provisioning, you can also get started with certificate signing at the very same time. And so we've made it super easy to get started with certificate issuance.
Yeah, I love that. I'll also love that Fabric dashboard that you had there that showed the validity of the certificates on each device as well, and whether anything had expired. That's super powerful just all on its own, I think, to be able to surface that sort of level of detail. And then the revocation process that you showed as well, super slick and smooth. Really love that. Excellent stuff.
Awesome,
Cool.
thank you.
Yeah. So we can move on to Isabella's section now.
Yeah, let me know that if you're able to see my slide deck again.
Yes, indeed we can.
Yes, you can
Cool.
see it. All right, awesome. So thank you so much, Seeam, for that great demo. Many of you may already be familiar with Azure Device Update for IoT Hub, or ADU for short. But as a quick refresher, ADU is Microsoft's over-the-air update service for IoT devices, and it provides a native update management experience directly integrated into IoT Hub. And this slide, it does a really good job at capturing some of the key capabilities that are available today, but I'm going to be quickly walking through a few of them at a very high level. So first, ADU exposes APIs that customers can use to automate update workflows or build their own management experiences. One of the strengths of ADU actually is its flexibility. So as long as a device has a compatible device update agent and an update handler, customers can use ADU across a very broad range of operating systems and also device types. So from Ubuntu and Debian to Yocto-based systems or even other custom embedded environments. So because the reference agent is open source, it's also very highly extensible for customers with very specialized requirements. So that's one of the key highlights. And we've also recently expanded support in our open source device update agent reference implementation to Debian 13 and Ubuntu 2404. So if you've been waiting for it, now it's your time to try it out. From an operations perspective, though, ADU provides a lot of flexibility in how updates are deployed. Customers can schedule deployments, they can roll out updates gradually, use dynamic deployments to automatically include new devices, and also perform multi-step updates where updates happen in a specific sequence with optional pre and also post-install actions. ADU also supports proxy updates for peripheral devices. And in this model, an IoT Hub connected parent device receives the update from ADU and sort of acts as a gateway for any downstream devices that don't connect directly to the cloud. So that's another really cool feature. And also with ADU, operators can get visibility through built-in monitoring, diagnostics, and reporting capabilities. And more recently, you'll see at the bottom of the slide, with the 1.3.0 release of our open source device update agent reference, we've expanded support to Debian 13, Ubuntu 2404, but we also introduced a new status API that gives applications running on the device visibility into what's happening on the update lifecycle. So, for example, an application can determine whether an update is downloading, installing, or even waiting for a reboot, and use that information to coordinate its own behavior. So, if you've been waiting for that support on those newer distributions, you should go ahead and try it out. But what's also most exciting is what Seeam has been repeatedly mentioning during the call, which is Delta updates. And Delta updates, they can significantly reduce the amount of data that devices need to download during an update. So let's take a closer look at how it works. So with that, let's go to the next slide.
Yep.
All right, so what exactly are Delta updates? So at a very high level, instead of downloading an entire software image every time there's an update, devices download only the differences between the version they're currently running and the version that the person is trying to deploy. So the device then would reconstruct the full target image locally and install it using the same process customers are already familiar with today. And then the device would still end up running the exact same software version. But the difference is that instead of downloading the entire image each time, it only downloads what changed. So looking at what's supported today, Delta updates are available for image-based updates using SW Update, which is the open source software update framework used by the current ADU reference implementation. They're also designed to work across fleets that may not all be on the same starting version. For example, if some devices are on version 1 and others are on version 2, you can provide the appropriate Delta packages for each path to a common target version. And to generate those deltas, Microsoft actually provides a div-gen tool as a reference tool that customers can use to generate deltas, and also they can integrate it as part of their Yocto-based build process. So we also offer some samples for that. So why would you choose Delta updates? So the biggest benefit is actually reducing the amount of data that devices need to download, which means lower bandwidth consumption across your fleet. And also in many scenarios, it also means faster downloads, especially over constrained networks. And another nice thing is that this doesn't really change the deployment experience operators are already familiar with in ADU. So devices still go through the same installation process and also the same rollback model as any other standard image-based updates that we support. So that's why Delta updates are, particularly useful, and they're also really useful when you're working with very large system images that only change incrementally between releases. And when you're shipping updates frequently, that's also a really good use case, or when devices are connected over cellular, satellite, or even low bandwidth networks where every megabyte counts. And of course, if most of the image has changed between releases, a traditional full image update may still make sense in that scenario. And Delta updates, they tend to provide the most value when the changes between the versions are relatively small. That way you can save a lot. So now let's take a look at how it works from the service side. And we're going to look at it on the next slide. All right, so in this example, let's say that the goal is to update devices to version 3. So the customer first builds the version 3 image and generates the Delta packages that correspond to the versions currently running in their fleet. In this example, you can see on the left side, that's a V1 to V3 Delta and a V2 to V3 Delta. So those artifacts are then imported into Azure Device Update and deployed just like any other update. And when the device checks in for the deployment, ADU then would evaluate the version currently running on that device and would select the appropriate update artifact. So for example, a device running on version 0 would receive the full V3 image. A device running on V1 would receive the V1 to V3 Delta, while a device on V2 would mainly only download the V2 to V3 Delta. And this mainly just allows customers to support fleets where devices are running on different software versions and still benefit from smaller updates. So to make this a little bit more tangible, let's take a look at a quick demo, and that will exemplify some of this more clearly. On the next slide.
Yeah. Let me know if you're able. Oh.
No, we can't hear it.
Yeah. I think
Oh, you can't hear?
Yeah, you might need to reshare with sound. I think there might be a tick box, is there? Possibly.
Right, let me stop sharing and then let me try sharing again with sound.
I can also share it from my side.
Oh, also share system audio. Yeah, okay.
Yeah, that'll be the one.
From factories to hospitals, IoT devices keep critical operations running. All of them depend on a steady stream of software updates, like security patches, bug fixes, and new features to stay secure, compliant, and reliable. But every update ships as a full image to every device, even when only a small part actually changed. At fleet scale, that's more bandwidth, more cost, and real-time your devices spend downloading instead of running, especially on slower or metered networks, where every megabyte counts. That's where Delta updates come in. Azure Device Update for IoT Hub already helps organizations around the world manage over-the-air updates at scale. And Delta updates extend that same workflow, so devices download only what changed between two image versions. Smaller updates, faster downloads, and less bandwidth across your fleet. So how does it work? Each time you build a new software image, you also generate a delta, a small file that captures only what changed between versions. The smaller the change, the larger the bandwidth savings. You then import it into Azure Device Update alongside the full target image. You can include multiple deltas in one update, so devices on different starting versions all take the most efficient path. On the device, two things make this possible. First, the Delta processor, a small extension you add to your device. It combines the Delta with the previous version of the image, cached on the device as the Delta's source, to rebuild the new one. Second, the update handler. It's the same one used for full image updates today, and it installs the rebuilt image, just like always. When you deploy, the device update agent checks the device's current version and looks for a matching delta in the update. If it finds one, it downloads just the delta. The Delta processor rebuilds the new image locally, and the update handler installs it. This works with A/B partitions, where the new image is written to the inactive one and becomes active after reboot, with the previous version kept as a fallback. If no compatible delta is available, the device falls back to the full image automatically. Same workflow, same result, just a lot less data on the wire. Let's see this in action. Contoso is a fictional company managing a large fleet of connected smart meters that track energy use across customer sites. Many of these meters run over cellular networks where every megabyte counts and frequent full image rollouts add up fast. Sarah, an engineer on Contoso's smart meter operations team, is evaluating Delta updates for her fleet. Starting from the device update agent reference implementation, she built and integrated her own agent with the Delta processor extension onto a Raspberry Pi. She's ready to see Delta updates in action before bringing the same integration into Contoso's fleet of 10,000 devices. Sarah has already set things up. On the cloud side, she has an Azure IoT Hub with a device update instance, and her Raspberry Pi is provisioned as a hub device and added to a test device update group. On the device side, the agent is configured to connect to her hub, and the Pi was previously updated to version 1 of Contoso's image, which the agent has cached locally. Over in the IoT Hub, Sarah checks the agent's reported properties on the device twin. It confirms v1 of Contoso's update is the latest deployed. On the Pi, Sarah checks the OS version 1.0.0.1, the image installed by the v1 deployment. She also confirms the device is on partition B. With everything in place, Sarah is ready to push a new version. In the Azure portal, Sarah heads to the Updates tab and starts a new import. She selects the full v2 image and the v1 to v2 Delta as part of the same update. And right here, she can see the value of Delta updates. The full v2 image is around 240 megabytes, while the v1 to v2 Delta carrying the same change is just 6. She then adds the import manifest and install script to complete the update. Once imported, Sarah sees the new update is available for her test group and starts a deployment. The deployment goes live, and her Pi is already in progress. A few minutes later, the agent triggers a reboot and the device restarts. Once the Pi is back up, Sarah reconnects and sees the deployment has succeeded. She checks the OS. It's now on version 1.0.0.2, running from partition A, as she expected. Over in the portal, the device twin tells the same story. The v2 deployment is now the latest. Curious about what happened under the hood, Sarah opens the logs. The v1 to v2 Delta came down at just 6 megabytes in about a second. The full v2 image, similar in size to the v1 image already cached on the device, would have been around 240 megabytes. The Delta moved 40 times less data in a fraction of the time for the same change. While the actual savings will depend on what changes between versions in the network, for small incremental updates like this one, the difference is hard to miss. The Delta download handler shows the rest of the workflow. It found the cached v1 image as the source, used it with the Delta to rebuild the full v2 image locally. From there, the update handler installed it, just like any full image. For Sarah, that's the proof she needed. Across Contoso's 10,000 meters on cellular, this single update saves roughly 2.3 terabytes of data, the kind of result worth bringing back to her team. Delta updates in Azure Device Update for IoT Hub solve exactly that. Smaller payloads, faster downloads, and less bandwidth across your fleet on the same deployment model your team already uses. Start with the Device Update Agent 1.3.0 open source reference implementation on GitHub. Integrate it, test it, and run your first Delta to measure the impact on your own fleet.
That was cool. I need that link so I can tweet that out, aka.ms something or other. I don't know what that was.
Totally, yeah. I'll send it out in the chat as well.
Brilliant.
Anyway. Good. Seeam, are you able to reshare the slides?
Yep. Let me share my screen again.
All right, so hopefully that all got you a little excited about what's possible with Delta updates, and would love for you to try it out, to try out the 1.3.0 reference implementation that we just released. And if you'd like to learn more, we recently also published both documentation and a tech community blog that go into much more detail into that. And here on this slide, we have a few links if you want to keep exploring after today. So the tech community blogs are at the top, and it's a great way to start because it covers the IoT Hub and also the Azure Device Registry Preview Refresh, which is the first link. And the other one goes deeper into Delta updates. It also has the link to the demo as well, and I'll be able to put the links in the chat in just a minute. And if you want more technical details, then we have the Microsoft Learn docs, which walk through what's supported and how to get started. So we recommend you to walk through them And we also have the GitHub link for the 1.3.0 release we just covered today, along with our open source and agent documentation. So hopefully this gives you a good starting point, and it also gets you excited to experiment a little bit with our preview refresh and Delta updates in your own environments. And with that, we can open the floor to any questions. And I'll put the links in the chat in just a second.
That was awesome. Really enjoyed that. And I've got millions of questions. As far as the updates are concerned, are we updating the whole OS here, or are we updating parts of the system that you've deployed, or what does that look like? Certainly for the Raspberry Pi example, I've got a lot of love for the Raspberry Pi. Is that Raspbian or something that we're updating there, or is it some form of bare metal OS that's deployed on it that we're updating?
Yeah, so we basically build the base image using Yocto. So it's a way to build your own custom image for any device. And we provide samples today in our documentation. And I'm happy to also share some of those links in the chat. And what happened in the video is that we had the full base image on the device. And when the device got it updated to V2, basically instead of downloading the entire OS, like the entire OS image, it only downloaded the difference between the version it currently had cached on the device and the version that was being sent down. So that's exactly how it works. It only downloads the Delta, which is also an artifact that the customer has to provide as part of the deployment. But based on the source image on the agent decides which one to download. So in this case, it downloaded the Delta because it was part of the update package. And if there's no Delta, of course, it will just continue to download the full image as it always does. Hopefully that answered the question.
Yeah, definitely. Is this a sort of a main OS type service, or would this work for embedded systems as well, or is the embedded world just too small, or what?
No, it also works for MCU class devices. So very like the less powerful set of devices besides the more powerful ones like the Debian-based ones that we support. So as long as the device can have the device update agent integrated in the device and run that, it can support Azure Device Update. So it's highly extensible, highly portable to many OS versions as long as the device update agent is on the device.
I like it. That's pretty cool. So it's entirely up to you whether or not you do the full update or the Delta update. You can control that yourself through the agent, and it doesn't make that decision on its own. Or have I got that wrong?
Yeah, so it depends on the implementation. So if you included the Delta download handler on the device, whenever as part of your deployment you include the Delta will be downloaded as long as you include the right version. So for example, if you include the V1 to V3 Delta and your device is currently on V1 and has the update cache locally, then that's how the agent will decide, okay, I see the Delta is present with that V1 as my starting point, and that's the starting point already on the device, so I'm going to download that. If there's no Delta present, then it will just download the full update, or if that Delta doesn't match the right path, it won't download the Delta, and it will just fall back to downloading the full image.
I like it. And the creation of the Deltas and the images on the other side, that's not something I've tried. What's involved in creating the Deltas? Is that programmatically relatively simple, or is it something that the owner of the operating system needs to have deep level detail to be able to do?
Yeah, so today we do provide some reference tooling, which is called our DivGen tool. It's also open source, it's a reference implementation, and that tool helps to build the Delta. But of course, we're open to feedback with this new feature as well, and hearing our customers and see how we can make it better. And that's how it works. And we also provide a way to sort of automate that run of that tool as part of the Yocto build process. And so it makes it easier for customers to do that. And we provide it as a sample reference in our GitHub docs.
I like it. And then I'll finish with one more question. On the device side, if one of the updates fails for whatever reason, does the agent take care of rolling back or switching partitions even, or is that entirely up to the operator to implement that?
It really depends on the implementation, but we do provide rollback capabilities. And like in the portal, when you're setting up the deployment, you can choose if you want to do automatic rollback, which is a good thing if something goes wrong. And we highly recommend to use that. And you can choose, and we have like percentages of failed devices that you can use as a threshold to determine when the rollback is going to happen. So let's say if 50% of my devices failed, then the rollback is going to be applied. And the customer also has the option to choose which update version to get the device to if the update fails. So
Yeah.
that's some of the things we provide.
I like it. I've got millions more questions, but I'll save them for another time. That was really good. Love both those demos. And thank you so much to Seeam and Isabella for taking the time to put that together. It was really cool to see. It's definitely on my list is Delta updates to go and take a look at and see what I can make happen with that. It's a really great feature to be added. What's interesting to see out of both of these is the amount of development and innovation that's happening around IoT Hub. And certainly I have heard it said that folks think that IoT Hub is finished. And I'm hoping that when folks start seeing this sort of information, they can see it is not, and that it's actively being developed. And it will continue to live on and be innovated upon by the folks there. So it's wonderful to see that. I've got a lot of love in my heart for IoT Hub. So
It shows.
It's a specific tool for a specific use case. So there will be use cases where something like IoT operations fits, and there will be use cases where something like IoT Hub fits, and the Microsoft IoT stack covers that end to end to be able to give you that choice of which way you implement. So great to see some of that stuff working there. Love it.
Thank you so much, Peter, for inviting us. This was amazing opportunity to share with everyone what we're doing. And thank you so much, Seeam, for those great demos. Anything else you want to add, Seeam?
No, thanks so much, Peter, for giving us this platform and opportunity to speak. Super excited to hear feedback continue to roll in. If you end up watching this live stream, once it's pre-recorded, Peter will link our LinkedIn profiles, all these documentation and whatnot. Feel free to reach out if you have feedback, questions, concerns. We're happy to address them and happy to talk more about the space. We really value feedback in our organization. So yeah, thanks so much for this opportunity.
Great stuff.
Feel free to reach out anytime.
Love it. So I'm going to end the live stream now, folks. So thank you very much for coming along and watching. Again, thanks to Seeam and Isabella for coming along and giving their talks there. As I've mentioned, I'll put all the links in the YouTube description for you to be able to